My name is Chris Collins. I am the author of Born Equal, a paper which was done on 4,477 athletes looking at their genes. And today we're going to have a quick video on do genetics make an athlete? So we're going to look at some of the big genes first, so ACTN3. Now, a lot of DNA companies test for this to see if you have fast or slow twitch muscle fibers. However, that's not really how it works. But as we can see that the CC genotype in ACTN3 in RS1815739, they actually predominated in power sports and bodybuilding, but about 2,087 of those had that. And we're looking at 77.7% of the athlete profiles that we looked at had that CC variation. The next one we want to look at is called MFTN, and that encodes for a protein called myostatin. Now, myostatin controls our muscle mass in the body, and actually having lower levels will incur greater hypertrophy gains. So if we can see here, the majority of athletes are in the AA category, with only a small number having a G or double G. Actually, only one athlete out of all 4,477 athletes had that GG. And actually, that athlete happens to be a 2 times world's strongest man. The AG category had 271 with a massive 93% or more actually competing in power, strength, and bodybuilding, with a good number of those actually competing at national, international level in their given sport. The next one we'll look at is a gene called NOS3, and this affects nitric oxide within the muscles, which you may know you sometimes take supplements to try and boost that. Now, the CC variant seems to be quite highly associated with endurance and stamina, and the TT variant seems to be associated with power sports. However, the power sport one is only around 78%, with the endurance one being around 90%. A good number of those in the TT category actually competed at a national level or higher in power sports. Now, ACE is a good gene to look at as well. Now, this has actually mainly been looked at for endurance activity, but we will look at it as for power predominantly, because the insertion of ACE, of RS4343, was more associated with power activity, and that association is really key, because it was actually in quite a high level of athletes having that, with 93.98%. There wasn't actually that many stats about how many competed at a higher or national level with that genotype. AMPD1 is really a big one as well. However, we can see that the majority of athletes are falling into that CC category, with a big number competing at that national, international level, with only a few actually having a T. However, there were 2 athletes with TT in this genotype, and they both actually compete at national level. So it doesn't seem to be that negatively affecting the endurance activity. And the final one we'll look at is TRHR, which is actually associated with lean body mass. As we can see that the CC variation is associated with power, strength, and bodybuilding, with a good number actually competing at national level or higher in bodybuilding. Now, TRHR, having that genotype within this gene, actually affects the amount of lean body mass somebody has naturally. So it will be easier for that person to preserve muscle mass whilst also losing body fat, which is obviously a massive boon if you are into bodybuilding. So the big question is, do you need to have certain genotypes to be an athlete? The answer is no. The only genotype really which shows great potential is myostatin, or the MSTN gene. However, the outcome to actually have that is so uncommon that it's more of a good head start or a high ceiling for somebody when they train. The majority of athletes competing at any level actually don't have the variant, so it's a good one to have. Now, obviously, having certain genotypes will predominate you towards a certain type of activity. Basically, it's your ceiling, your training ceiling, or genetic ceiling, if you like. Some people will be able to get a better endurance, stamina, VO2 max than others. Some people will be able to build more power than others. And this is independent, really, from anything else. So if somebody, for example, was to take performance enhancing drugs, these genetic limits will still exist, and the drugs allow them to maybe push through certain aspects, but they will still be limited by certain genotypes. And there are other genotypes which are associated with how one might respond to a performance enhancing drug. So it's not just these genotypes which are important, but for those who are taking supplements and drugs, those genotypes which are associated with metabolizing those will also be important for performance. So in essence, you don't need to have the perfect genes, and actually nobody does. But knowing what type of genotypes may be predominant in you, what may aid you in changing the way you train, for example. Maybe you require more rest periods. It might alter the way that you go about your sport. So, for example, if you were a 60-meter, 100-meter sprinter, you may actually find that you're more successful doing 400 meters. Now, it may also affect the way you bodybuild, for example. So some people actually build more muscle with a slower time under tension, and some people build more with a power-based session, and that depends on their genotypes. It also depends on the kind of supplements they will and will not respond to, and that can also be looked at.